Good evening. Welcome to ISU Media Message. I'm Bob Lindemeyer, Associate Director of the Media Resources Center here at Iowa State. And our program, as hopefully many of you know by now, has a really very simple and straightforward purpose. Our purpose is to give you, our television audience, an opportunity to see some of the fine films and videotapes that have been produced here at the university. Programs that normally are just seen in classrooms or for very unique and specific sort of targeted audiences, as opposed to the wider television audience. My guest today is Laura Wingert, who's instructor of engineering fundamentals, College of Engineering here at Iowa State. What are the engineering fundamentals, Laura?
The engineering fundamentals are things like engineering graphics, drawing, design, using CAD, programs, Fortran programming.
Typically, these courses are taught during the freshman year to
That's
all
right.
engineering students.
That's right.
They study a lot of calculus and chemistry and physics,
That's right.
as well as these fundamental courses.
That's right, along with some English, a little bit.
Okay. Yeah, we have to be able to communicate as engineers, too. Now, I know that the engineering college is on a real initiative to try and describe the engineering careers and the value of being involved in engineering and scientific disciplines to what a wide range of population.
A very wide range, yes.
That's what generated the big book that we've heard a little bit about
That's right.
being done in the engineering college. That big book is used by what level of teachers?
Primary school teachers, kindergarten, first grade, second grade teachers, right now are using the big book.
It's been distributed widely, I guess, around the state?
Around the state, and we've also been taking orders across the country and also internationally now for the
Good.
big book.
Well, the videotape that we're going to see tonight that you've brought us is going to be seen by a wide number of people, we hope, too.
That's right.
Let's have a look at it now, and then we'll come back and talk some more with Laura Wingert. Here's our videotape for tonight. It's called Engineering Game Plans.
Engineering is all around us. It's just a matter of looking past the obvious. Most things made by people have been touched in some way by engineers. Different kinds of engineers work on different kinds of products, each one created from a design, a game plan, based on the rules of science and mathematics. After designing a product, engineers then plan how it can be created, until it's ready for us to use, from footballs to football stadiums and more. Let's look past the obvious to see how engineering game plans have resulted in some of the things we see and use. A car. It's a very complex piece of machinery. So many kinds of engineers have a hand in its design. But the mechanical parts of a car are usually designed by a mechanical engineer.
Some engineers, mechanical engineers, may work on the air conditioning, heating of the car, on the starter of the car. A lot of the engineers may just work with the transmission and the gears. They may work on the suspension of the vehicles, how you would change the design of the car for the driver. We do a lot of computer simulations of the driver in the car. We'll get parameters from companies like GM and Ford and Chrysler, and we can run those on the computer. When an engineer designs a car, it has to work. And all these things that I've mentioned, the transmission, heating, air conditioning, the gears, all have to work, as well as that it looks good.
Cars aren't the only things engineers design. What else do you see that could be designed by an engineer? The football stadium is a large structure, and large structures like stadiums, school buildings, bridges, even airplanes are designed by engineers, structural engineers.
Basically, a structural engineer will match material with force, matching enough material to get a structure that will stand up under loads, be it man-made or being forces of nature. The force of nature primarily there would be the wind loads on the structure, but then the other load we take into account would be the occupancy load, the fan load that comes. It's not only a static load when they're sitting there, but also a dynamic when they move in and out of the stadium and respond to exciting events on the field. If you look at those two large columns coming down, obviously they're putting the force on the soil, so we had to distribute that load. So underneath the walkway we have foundations. The structural engineer would work with the geotech engineer. The geotech engineer would tell the structural engineer how strong the soil was, and then the structural engineer would figure out how large the footings had to be so he didn't overstress the soil.
After structures are designed, someone has to build them. There are even game plans for building things, and engineers once again design their own plans for construction.
Construction engineering is the coordination of people, is the coordination of the tools and equipment, and the plan for building a structure. They work on highways, they work on roads, they work on all sorts of facilities that you walk into every day and never think about who built them. Construction engineers rely on their business training, they rely on their law training, they rely on their engineering training to make sure the constructed facility is built on time, under budget, at the acceptable quality, and without hurting anybody. Construction engineers have the unique ability to take two-dimensional plans, basically lines on sheets of paper, and turn them into a three-dimensional finished product. We wouldn't have the large skyscrapers, airports, bridges, shopping malls, if it weren't for those construction engineers to help get them built.
Football is an exacting sport. The coach engineers the game plan around the player's strengths and around the physical properties of the football field and the football itself. The football's unusual shape is an important part of how the game is played.
The football is basically in an unstable shape, and the only reason we can play with it is the fact that the quarterback spins the football, and that spinning gives it the aerodynamic stability that's necessary. And that's what aerospace engineers do also. They worry about stability. That is, once you put an airplane in the air, you want it to go where you want it to go. You want it to stay in the same direction. So it must be stable. The aerospace engineer studies the flow of air about the space shuttle, the structural characteristics of the machine. How can you build it so that it will hang together in flight? We've already gone to the moon, and eventually we'll go to Mars. That trip to Mars will have to be in a vehicle that's designed by engineers, people who know the mechanics of nature, the laws of physics, and who are able to use those laws to design a vehicle which can go in the right direction and is safe and can get there and come back.
Footballs take a lot of punishment, and they seem to hold up pretty well. That indicates good quality. Yet thousands of footballs are made and sold every year. How can such a high-quality product be manufactured at a cost most of us can afford? That's a question for an industrial engineer.
Footballs are like any other product that's mass-produced. They start from raw materials and go through a number of steps until the product is finished. For example, to produce a football, the leather is first cut into pieces, and those pieces are sewn together, and the ball is turned right side out. Then it's laced and inflated and then checked to make sure that all the balls are the same size and weight. An industrial engineer looks at the entire manufacturing process And by considering the materials, the equipment, the people, the time and money involved, they can determine the best way of producing the product. Industrial engineers work in every industry, from manufacturing hot dogs to airplanes. Just try to think of something that's been produced without an industrial engineer.
Halftime. 50,000 football fans taking a break at the same time. A product we all take for granted is water, but it has to get to us somehow. The engineer responsible for supplying and disposing of our water is the civil engineer.
One of the problems civil engineers face is supplying water to facilities and collecting the wastewater and taking it away. For example, the civil engineer has to decide how many toilets and how many drinking fountains and how many wash basins have to be provided, and how big the pipes must be to serve those facilities. You must keep in mind that during the halftime you get a big demand put on these facilities, because every time somebody flushes the toilet it takes about 25 gallons per minute, and several toilets may be flushed at the same time. Similarly, the plumbing that collects these waters and discharges it away from the facility has to be designed by the civil engineer, and has to be big enough to collect all that wastewater. Otherwise, the toilets might flood when you flush them, and you'd have a real mess on your hands. So the civil engineer faces some real problems in a facility of this type.
As with water, we also take our food for granted. Behind the scenes are agricultural engineers who help make that food available to us.
Agricultural engineers are among those people who find easy ways to get the food from the farm to your stomach. Agricultural and biosystems engineers develop efficient ways to plant, care for, and harvest the crops, and develop ways to care for the farm animals, both of which are made into the foods that we eat. They do this by designing farm machinery, housing for livestock, food processing systems, and other systems that make the producer's work easier and more efficient and less costly. Ag engineers also help design machines that process the crops after it leaves the farm. We use our knowledge of math and science to solve the many practical problems of processing the crops into tasty foods that we eat, so that they're not only fresh and tasty, but also affordable. From the meat and vegetable and the milk on your dinner table, to the hot dog and the drink at the stadium.
Have you ever thought about the surface these players are playing on? It's not grass, it's artificial, made from chemicals, designed by engineers.
Artificial turf didn't get here by accident. It wasn't grown. It was developed in a laboratory and manufactured in a processing plant. Chemists and chemical engineers play key roles in its development and production. The chemist, inventor, had to consider several important properties that it had to have, such as being tough and resilient to withstand 200 to 300-pound muscle men diving and stomping all over it. It had to be waterproof, but still be able to pass water through it. And it had to last a long time because it's very expensive to replace. After developing it in a laboratory, the chemical engineer had to find a way to produce it on a very large scale. To do all this profitably, chemical engineers have to rely on academic training in math, science, and engineering, not to mention a degree of creativity, determination, experience, and yes, even intuition.
Wherever we look, engineering is all around us. But it's hard to see, almost invisible, like the unseen electrical signals running through the wires. Electricity carries power to work a lot of devices. But it can also carry information, computer information that can program those devices to work in different ways. These are two closely related areas, electrical engineering, and computer engineering.
Any significant design project anymore is going to involve engineers from all disciplines. And the electrical engineer will specialize in working with the electrical principles, those principles that deal with the use of electricity, and the generation of electrical power, design of electrical circuits. They're also involved in electronics, the things that make your TV set go, your CD players go, those sorts of things. Computer engineers are involved again in the programming of these devices to give them their personality or their character. It's hard to conceive of any industry that does not need the skills that computer engineering students or electrical engineering students can bring to the table.
Football is a grueling physical sport where injuries can be a major factor. Biomedical engineers create and improve many devices in the health field.
Nobody likes to see the linemen or anybody else, the running backs, get hit on the side, a lateral impact, and see the knees pop or see them cringe in pain. But what I was trying to do relates to that. I was trying to simulate those activities and not risking anybody's knee by doing it on the field. The knee brace, after talking to the head trainer here at Iowa State, identified his brace, and looking at it, because it was so flexible, it led me to think, well, how can this brace be as protective as it needs to be? How can we make it better, or could it be made better? And so I tested different materials, and I was trying to prove that stiffer materials, things like aluminum or graphite, would be better because they resisted bending. It takes a broad knowledge in math and science. I use some very common things out of physics, gravitational laws, the laws dealing with pendulums, motion of pendulums, the velocity and the momentum, stuff like that. So it was a lot of number crunching, adding, dividing, subtracting, averages, the things that you have to learn in school. The health field is demanding a lot from the engineering field. New instruments, new devices to use in the hospitals, CAT scanners, magnetic resonance, all kinds of different things. And all of that is within the scope of biomedical engineering.
Materials. Everything is made of something, usually something made by people, like the turf or the steel and concrete of the stadium. Engineers who design materials are called material scientists.
A material scientist is someone who studies the structure and properties of materials to determine how we can engineer them or alter them to suit our specific purposes. So with the materials that we develop, we sort of hand them over to another type of engineer who incorporates them into some sort of design for a real product. Sometimes we work with civil engineers to work on structural materials, or maybe we work with biomedical engineers for materials that are used specifically in biomedical implants. For the semiconductor manufacturing or electronic materials, we work with electrical engineers and find out what their needs are. So we've just got a huge variety. There are people that are working on things for aerospace applications, and what we get to do in our field is work with all the other fields and find out a lot about a lot of different things.
A lot of different things. That's what engineering is. So what does it all boil down to?
Engineering is just a very exciting field because you get to use your creativity as well as your technical skills, the math and the physics and the science that you've learned.
It gives a person the chance to design things that help people.
Engineering would be fun for those that enjoy using their mind in math and science.
There are always new problems to be solved and new ways of doing things.
And a sense of pride because you've seen a product developed from ground level up until it's marketed.
So I'm excited about where I'm at and also what the future is going to be like.
So it's always a challenge, and it's always fun.
Well, there you have it, engineering game plans. And my guest is Laura Wingert, instructor of engineering fundamentals here in the Engineering College at Iowa State. Laura, it's really an interesting tape. The idea of sort of conceiving all these engineering disciplines around what goes on at the football game came from where? I know you did some early planning in the development.
Well, I wanted to come up with a project that would really interest 8th grade students in engineering. And the typical tour through a factory, I didn't think that was going to do it. So I tried to come up with an idea, something that they would be interested in, something that would be fun, that would tell them that engineers work on fun projects, as well as some important other projects.
So your target audience with this tape is 8th graders, 9th graders, sort of what do we call junior high, middle school?
Mm-hmm.
Okay. Mm-hmm. And you had some people that teach math at that level serve with your advisory committee, as I recall.
Yes, we had one counselor from a middle school, and he helped us come up with some ideas.
Okay.
And we just decided to look at the different aspects of football that come from engineering.
Now, has the finished tape been, I realize it's just been finished very recently, but has it been evaluated by that target group of students?
We had some preliminary evaluations done a couple months ago, and the students were very positive. They liked it a lot.
Okay.
They said they learned a lot from it. They were excited about engineering, and they hadn't known before really what engineering was. So that was
that's
good.
Great. Now, as I recall, it's going to be sent out widely to schools. Tell us about the distribution plans.
Right now we're planning to distribute it to every middle school in the state of Iowa. Each school will receive a tape, and then each 8th grade math teacher will receive a resource manual to be used with the tape.
Oh, tell us about the manual.
The resource manual is an 8-page manual, and it has sample story problems that relate directly to the video. We'll be calculating, how much turf is needed, if it costs so much per square foot, etc. So they're actually doing problems that engineers would do relating to football games. And
if all those toilets flush at the same time, how much water is required?
That's right. That's exactly right.
Okay.
So hopefully that will help the math teachers tie in what they're studying in math class to what engineering is and what engineers do.
All right. Now, if someone is interested in getting a copy of the tape or that resource manual, I assume there's a way that they can write into us here at the Engineering College.
They can write or call to the Engineering Student Services office.
Oh, here it is on our monitor now.
Okay.
Good. Engineering Student Services at 110 Marston. Or call, I guess, too, huh?
That's right. And we can send an order form, and then they can get a copy.
Okay. How many copies have actually been distributed initially? I think you said to every middle school in the state?
That's right. We're sending out about 500.
Oh, wow.
Just over 500 tapes initially.
Okay. Let's talk a little bit about the interest that the college has really been demonstrating in terms of encouraging engineering and science disciplines. We talked earlier about the big book for the little folks. But I know there's a thrust going on that's called the NSF Coalition. Tell me a little bit about that.
The National Science Foundation has sponsored an engineering synthesis coalition, and it consists of 10 colleges, universities across the country, and we're working on keeping students interested in math and science so that eventually they can be involved in math, science, and engineering careers, because research has been showing that there's going to be a shortage of engineers and scientific professionals in the future. So we're trying to keep students interested in that and getting them on the right track early on so that they're prepared for college courses.
Do you face up honestly with them to the fact that they need to have their math skills and their chemistry at the high school level in good shape?
Well, yeah, I mean, that's why we want to get them interested early so that they can be aware that they need the math, but also helping encourage them that engineering can be exciting and fun.
Sure.
Can help encourage them to take those courses.
Well, we had a guest on our series earlier about the Women in Science and Engineering program, and I guess you're a good example of that yourself. You have a bachelor's degree in some field of engineering, right?
In industrial engineering.
Industrial engineering, okay. Well, it's been very interesting having you here tonight, and we're going to look forward to hearing more about the response that comes from this tape. I'd be thrilled to find out what happens when we show this tape to a junior high crowd from Iowa City, for example, with all that Cyclone football going on in the show.
Yeah, it'll be interesting to see what they think of that.
Okay. Thanks for being with us, Laura.
Thank you.
My guest today has been Laura Wingert, instructor of engineering fundamentals here at Iowa State. I hope you'll join us here next week for another issue of ISU Media Message.